This is R.D. Sharma Solution, Class 12, Chapter 10, Differentiability. MCQ multiple choice question we are taking. Now fx is this function when x is not equal to negative 2. So when it is not equal to negative 2, you have to use this function. Otherwise, when x is equal to negative 2, there is a constant function which is 2. So you have to show whether it is continuous, not continuous, differentiable, non-differentiable. So we have to do it properly the way we have been doing it. Okay. The main thing here is the modulus of x plus 2. So when we have x equals negative 2, if you go left, you will get positive. You go right, you will get right. Go right, you get positive. You go left, you get negative. Right? So we'll start with the continuity and then we'll go to the differentiability. Since the modulus is involved and you already know what to do with the modulus when it is positive, when it is negative. So when it is not equal to negative 2, you have to use this because that is what we are going to use in the left hand limit and right hand limit. And since it is modulus x plus 2, I already told you the inside one, just put it as 0. Whatever value x comes, that is the point which decides whether the values will be negative or positive. Left, it will be negative. Right, it will be positive. I hope you got the idea. So on the left, you are going to use negative x plus 2. On the right, we are going to use x plus 2. So fx is equal to, this is our function. And since we have to check at x equals negative 2. So let me just give you this function with all these boundaries. So it will be negative x plus 2 when you are less than negative 2. When you are greater than 2, then of course you have to use the function as x plus 2 as I explained. And modulus we are opening, that's why. So we have tan inverse x plus 2 here. And when x is equal to negative 2, then what? When x is equal to negative 2, it is already given as 2. So left hand limit and right hand limit we are going to compute. To find out, we'll have to check at x equals to negative 2. So x equals to negative 2 minus h we have to do. And x equals negative 2 plus h on the right hand limit. So when you go on the left, you just subtract a very, very small number that is called h, which will be eventually equal to 0. When you go up ahead on the right, we just have to add a very small value, very small h, and that is going to be your 0 of eventually. So this, when you start, you have to write limit x tends to 2 minus. That is to indicate that you are going on the left. Similarly, on the right, you have to write limit x tends to 2 plus in order to tell that I am going on the right. So 2 plus. But we know what is the function. When you go on the left, you have to use negative x plus 2 divided by tan inverse x plus 2. This is what you have to use. And when we go on the right, so positive function you have to use. So limit x tends to 2 plus. So x will replace just by minus 2 plus h and change the limit in the second step. But here you have to put x plus 2 tan inverse x plus 2. Now we'll replace x by negative 2 minus h. So this is going to be minus, in place of x is minus 2 minus h. So this gets cancelled, you get a positive h. So in the numerator, it's only h. In the denominator, it is x plus 2. So eventually it will be negative 2 minus h plus 2. 2 gets cancelled, negative h. So you have tan inverse negative h. And this is, you have to change the limit here, limit h tends to 0. So I just change the limit here also. You have to change the limit. Limit h tends to 0. And this x plus 2, replace x by minus 2 plus h. So minus 2 plus h and 2 gets cancelled. H by tan inverse x plus 2. So you have tan inverse x plus 2. So x is minus 2 plus h. And then we have a 2 here. 2 gets cancelled. H is there. So tan inverse h it will be. Now please remember, sine minus theta is minus sine theta, tan minus theta is minus tan theta, tan inverse minus theta is minus tan inverse theta, right? Tan inverse negative theta is negative tan inverse theta. Also, sine theta by theta or tan theta by theta, limit theta tends to 0, this amounts to 1. This is equal to 1. So this is tan inverse h by h only. If you take h in the denominator, it will be eventually equal to that only. So this is applying the limit in the numerator denominator. So we can apply the limit in the denominator, assuming it to be tan inverse h by h. And since we have a negative h, so we have to take a negative outside. And tan inverse h by h, I'm taking the numerator into the denominator. Just to show you that theta by sin theta or sin theta by theta both amounts to, when you take limit theta tends to 0, both amounts to 1. So you have tan inverse h by h as 1. There was a negative because of the tan inverse minus h, so minus 1 comes. On the right, you see tan inverse h by h, same thing, tan theta by theta, tan inverse theta by theta, that is going to be 1. When the theta tends to 0, so this is going to give you 1. So negative 1 and 1, so they are not equal. That is, this function is not continuous. So when it is not continuous, why would you check for the differentiability? You won't. Okay? This function is not continuous. So just write it is not continuous at x equals to negative 2. Let fx is equal to x plus modulus x, or the absolute value of x, multiplied by modulus x or absolute value of x. So please remember, there are three things being asked. F, f dash and f double dash. So three kind of differentiation we have to do. We are in the chapter of differentiability, so we don't have to, we have to worry about how did we can solve, or how are we going to solve the question of differentiation, because this is not the chapter of differentiation, this is just differentiability. But since the question is asking about for f dash and f double dash, we have to differentiate. So I'll give you an idea. F dash we have to find out, f double dash as. So you can see f is continuous, f dash is continuous, f double dash is continuous. Three options are there. One more option is there. F is differentiable for some x. Right? So let us see the continuity. First let us talk about this function. I'll tell you about this function. How are we going to actually find out the final value of this function? When we have to deal with the modulus x, it becomes somewhat tricky. So we have x plus modulus x into modulus x. Multiply this modulus x inside, so you get x into modulus x plus modulus x into modulus x. It is going to be modulus x whole square. So we have this modulus x whole square will always be x square. Modulus x is x when x is greater than or equal to 0. It is going to be negative x when x is less than 0. But when you square it, modulus square, it is going to be squared here also, x square and negative x whole square. So x square and negative x square both will be x square eventually. Right? So this is going to be x square. Modulus x square is eventually equal to x square only. So you can just write it as x square, because when you square the negative, it will always be positive. So what do you get? X into modulus x plus x square. Okay. Now let us find out and write the proper fx. The proper fx will be only dependent on the modulus which is left here. So modulus x, again x when x is greater than or equal to 0, negative x when x is less than 0, right? So we'll write it here, x into, when x is greater than or equal to 0, this modulus x will be negative x, positive x. When x is less than 0, it is going to be negative x. So just replace this modulus x by negative x, okay? So this is x into x will be x square plus x square is 2x square. So x is greater than or equal to 0. X is less than 0, what do you get? X into minus x is minus x square plus x square. These both gets cancelled, you get a 0. So fx, this is the final f function which we have to use. Please remember, we have to do the f dash, we have to do the f double dash also. That is double differentiation we have to do. 1, 2, 3. 3 steps we have to go. So this function I am going to use again. I am just clearing it. So then we'll start with the continuity of all these. Okay, so left hand limit and right hand limit, that we have been doing up till now. And left hand limit and right hand limit for what? Of course 0, because Modulus is all dependent. When it is simply modulus x, it is all dependent on 0. When you have modulus x plus 2 or x minus 3, that amounts to some other value where on left and right you will go differently. So here we have this 2x square when you go on right. You will have 0 when you go on left. So x is 0 minus, that is saying that we are going on the left of 0. And then you have to write, when you are going x less than 0, I told you it is 0. When you go on the right, it is going to be 2x square. So please remember, when we apply this 0 minus and 0 minus h and 0 plus h, when it is the result of division by 0. For example, 0 raised to 0, 0 by 0, infinite by 0, whatever it is. It all boils down, or it all comes down to the division by 0. So whenever we have something of division by 0, then we apply the L hospital rule, or then we apply 0 minus h, whatever is suitable to us. Okay? 0 minus h and 0 plus h is only applied there. You can apply it here also. But since I know that I am not going to get any value of division by 0, so I can apply directly here. So just apply x as 0 in both left hand limit and right hand limit. So 0 on right hand side also 2 into 0 square is 0. So left hand limit and right hand limit both are same, so f is continuous. You have to find out the value of the function at this 0 also. So when you apply this f0, you will see that value also will be, because 2x square, 2 into 0 square, that is again 0. And what about the differentiability? Fx minus fc by x minus c. Limit extends to c. This is the formula we apply. Or this is the, you can say, the precursor of the first principle. The left hand derivative, right hand derivative, you go to the left, you will use fx as 0. 0 minus on the right, it will be fx will be 2x square. So let me just complete this fx first, then I'll write the other values. So when you go on the right, it is going to be 2x square. So you can just write 2x square in this place. 2x square here. Okay, what is fc? What is f0? I just told you. f0 is what? Just put the value of 0. What is the equality? 2x square came when x was greater than or equal to 0. So it is the equality. 2 into 0 square is 0. So fc is 0. f0 is 0. Divided by x minus c. X, you can keep x like that, because we are not replacing it by 0 minus h or 0 plus h. But c, of course, we are checking at 0, so c is 0. So x minus 0 here. So eventually what do we get? Final one. 0 minus 0 is 0, 0 by x, so it is going to be 0. You know, this is 0 on the left, and then when we apply this one, 2x square by x, x gets cancelled, apply x as 0, so 2 into 0 is going to be 0. See, I have not used h here. So the left hand derivative and right hand derivative both become 0. So when you say that left hand derivative, right hand derivative both are 0, you can easily say that this function f is differentiable at x equals to 0. Not at some x. The option given in your question is f is differentiable for some x. But we are talking about it is only differentiable at x equal to 0. Other points we don't know. So the second option cannot be true. First is true, that we have already checked. Now there are two more things, f dash and f double dash. So I am clearing it again. Now we are going to f dash. So let me write function again fx. And f dash, why we are finding out? We have to take the differentiation of this. So 2x square differentiation is 2 is a constant, so it won't be differentiated. And x square will be differentiated, x square will be 2x. So 2 into 2x is 4x. Again, let me tell you, this is the chapter of differentiability we are doing. F dash and f double dash has nothing to do here. That is, the proper differentiation has nothing to do here. Okay? But since we are given the question, f dash will be 0 for x less than 0. 0 of differentiation of 0 is 0 only. Now we'll check the left hand derivative and right hand derivative, or you can say the left hand limit and right hand limit of the derivative. We checked it for fx. Now we are checking it for f dash x. So limit x tends to 0 minus, here limit x tends to 0 plus. Okay. So 0 minus means you are going on the left, that is you are going to use function as 0. When you go on the right, you have to use the function as 4x. Okay, so let us see here. You have a 0 and 4x. Now you can just apply limit directly because there is nothing of 0 division by 0 form. So 0, 0, when you apply x as 0, left hand and right hand both are 0. That means the f dash is differentiable. When it is differentiable, it will be continuous also. F dash 0 also will be 4 into 0, that is going to be 0. So these all value, left hand limit and right hand limit and the value of the function at 0 for the f dash x or the derivative of this function fx, all the trio, all the three things are coming same. So they are differentiable. When it is differential, it is continuous only. Right? I hope you got the idea. Now we are not stopping here. We have to do it for f double dash also. So f dash x, this is continuous. I'm just, there may be some mistakes here and there. So you just have to forgive me for that. So this is continuous at x equal to 0. Right? All are coming 0. Now coming to the f double dash x. F dash is continuous. Yes, you can say. You can say that f dash is continuous. Because once you have checked the differentiability, you can always say that f dash is continuous. Because the continuity is not the guarantee of differentiability, but the differentiability vice versa is the guarantee of continuity. Right? Okay. So f is continuous is correct. F is differentiable for some x is not correct. F dash is continuous. We have checked it out. It is correct. Now coming to f double dash x. So we have to differentiate it again. We started with the function 2x square and 0. Then we said 4x and 0. Now third one is f double dash x, which is again the differentiation of 4x and 0. This one. Again a differentiation of this one. So f double dash x, let us take the differentiation of this. So 4 into 1, that is 4. 0 is 0. So x is greater than or equal to 0, it will be 4. X is less than 0, it is going to be 0. Right? So this is the left hand limit and right hand limit for the second derivative. X is 0 minus, x is 0 plus, and even if you apply h or whatever, it doesn't matter, but this is a constant function. If you go on the right, it is always 4. When you go on the left, it will always be 0. So 4 and 0, whether you apply limit or not, it won't affect. 0 and 4 are the final values. They are not matching. So the left hand derivative and right hand derivative of the derivative f double dash x is not coming equal. So it is not continuous, it is discontinuous. So what is the answer? F is continuous, f dash is continuous. Okay. The function fx is equal to e raised to the power negative modulus x. So there are different options here, and we will try to check the trivial way. We will just first eliminate the modulus, then we'll do the LHL and RHL, then we'll do LHL and RHL for the derivative. That's what we are going to do. So modulus x is x when x is greater than or equal to 0. It is negative x when x is less than 0. By now you might have mugged it up. You have been feeded with this modulus x number of times. So when x is greater than or equal to 0, replace modulus x by just x. So it will be e raised to the power minus x. When x is less than 0, you have to replace modulus x by negative x. So it will be e raised to the power minus of minus x. So you get x greater than or equal to 0, e raised to the power minus x, and x less than 0, e raised x. So there is a slight correction in the answer which I have provided you on the right solution. So there is a slight correction. Okay, this will be the final verdict. Okay, so this is what you get while you remove, or you can say you solve the modulus x. This final, so I'm just changing this. X greater than or equal to 0, it is e raised negative x. So you have to remember, because I'm gonna do the derivative also in a short while. First we'll do the left hand limit and right hand limit. So this is the number line, just to show you that we are at 0. On the right we are going to use e raise minus x. On the left, you are going to use e raise x. Okay. Now, what you can do here is you can replace this x equal to 0. Of course, when you are doing it x as 0 minus and limit x tends to 0 plus, you are just telling that I am going to take the left function or the function which is when x is less than 0. So, e raise x you are going to use, and when you are x tends to 0 plus, you will use the function on the right. So, e raise minus x. Since you can always write x as 0 minus h and 0 plus h, but I know and we know that if I replace x by 0, we are not going to get any untoward, indiscriminate, undescribable value. That is, anything with division by 0 is a cause of concern. But we don't have any concern here because e to the power anything will not give you any untoward result until it is 1 by e raised to the power infinity. Okay. So anything to the power 0 is always 1. So e raised to the power, when you apply the limit e raised to power x, that is e raised to the power 0, you get 1. Here also, when you apply this x equals 0, so e raised to the power of minus x is 1 by e raised to the power x, and when you apply this 1 by e raised to 0, you get 1 by 1. So left hand and right hand, you see both are giving you 1, and the value of the function at 0, that is, if you actually put fx equals to e raised to the power minus x for x greater than or equal to 0, you get the value f0 as what? This is equality. So e raised to the power minus 0, that is going to be e raised to the power 0, 1 by e raised to the power 0, 1 by 1 is 1. I hope you got the idea. The left hand limit and right hand limit and the value of the function at 0, all these three are same. So the function is continuous at x equals to 0. That is being established right now. We are going to check for the differentiability. Now the second step is the differentiability. So left hand derivative and right hand derivative. Okay. There are multiple ways to solve it. Most of the books and solutions, they have given different solutions. But we'll go by the way we have learned, fx minus fc by x minus c. Fx is of course the function which I told you on the left and right what you have to use. So fx minus 1, fc is 1 because f0 is 1, I just showed you. X minus c is of course 0 here. So this fx minus 1 by x we are going to use. Final one is this, that we can always use on the LHD and RHD. So x 0 minus h you can put, x as 0 plus h you can put here. So the function will be on the left, you are going to use what? When you are x less than 0, e to the power x. As I told you in the beginning, the function is e raised x on the left, on the right it is e raised to the power minus x. Right? Okay. So we will put 0 minus h and 0 plus h, and they will try to find out or use a certain identity or already established result. So e raise x here, e raise minus x here. E raise minus x here. E raise x minus 1 by x, e raise minus x minus 1 by x. So what is this? Limit x tends to 0 minus here, limit x tends to 0 plus here. And now replace it by 0 minus h and 0 plus h. So you have to change the limit. Limit will be limit h tends to 0. E raise 0 minus h is minus h only. 0 plus h is h only. So e raised to the power 0 minus h, that is minus h minus 1, and negative h in the denominator. On the right hand derivative, it will be limit h tends to 0, e raised to the power h you have to replace, so minus h, minus 1 by h is h only. Okay. Now please remember, e raised to the power x minus 1 by x, limit x tends to 0 is 1. That we already know. We have used it. Log version, e raise x version, we already know. E raise x minus 1 by x, limit x tends to 0 is already 1. That we already know by our previous classes and our experience. Here we have on the left minus h and minus h, so you can assume it to be x. Here you have minus h, but in the denominator you don't have minus, so I am introducing on the right hand derivative negative. Here you have e raise x minus 1 by x form, so it is, when you apply the limit it will be 1. Here you have e raised x minus 1. So we have introduced a negative, so now this becomes 1, but there is a negative also, so it will be negative 1. So you have 1 on the left, negative 1 on the right. So left hand derivative and right hand derivative. What did we get? One is coming as 1, one is coming as negative 1, so they are not matching. So the function is not differentiable at x equals to 0. Though it was continuous at x equals to 0, it is not differentiable at x equal to 0. Okay, so the option will be, the answer will be, it is continuous everywhere but not differentiable at x equals to 0. This is a solution. I don't know, there are certain solutions which are not correct, so I just want to put it here so that you to understand that all the solutions are not correct. You have to follow the rules and the regulations of mathematics. The in-depth study will give you that thing. All these solutions which are everywhere may not be correct always. Okay, this type of question we are going to take in the later part. Till then, thank you so much. Take care of yourself.